All right, it's your favorite math teacher, or at least the one you're forced to listen to here to get a couple points in your homework category. A couple days after the Packer loss, I'm finally starting to work my way through it, and seeing you guys stay in school helped out a ton. So anyways, let's get to this. This is section 11.2 in your book. Some of the stuff from it, we're going to be working with circles and introducing arcs to you guys and dealing with central angles, and I think you'll see a lot of this is very familiar with some of the vertical angle and linear pair angles we dealt with first semester. So here we go. We got a circle, and we know a full circle is 360 degrees. Now, in a circle, you can break a circle up into chunks, and those chunks are curves. Those curves are called arcs. Now, we're going to look at three different types of arcs. There's a minor arc, which is an arc that's under the age of 21. I'm just kidding. Okay, a minor arc is an arc whose distance is less than half the circle, or whose number of degrees is less than 180 degrees. Now we name a minor arc, and this is an example of one, this red segment here, or this red arc here. We name it by the two endpoints that contain the arc. So we would name this arc AB, and we put a little arc symbol over it. If you want to put arc BA, that would be acceptable as well. But again, a minor arc has to be less than 180 degrees. The next kind of arc is called a major arc. And a major arc is an arc that is just above lieutenant in the military. Just kidding, another funny joke, okay? But what a major arc really is, and you probably guessed it, it's an arc that's more than half the circle. So, if we're looking at the circle, and we want to go from B all the way to C, following this green path here, that would be an example of a major arc. Now, naming these is kind of tricky, because when we name a major arc, we have to use three letters. We can't just put BC. If we were to call that arc BC and call it a major arc, we're incorrect. Remember, there's two ways to go from one point on a circle to the other. Either the short route, which is called the minor arc, and that's the one we use two letters with, which would mean this is incorrect, because we'd be talking about the shortest way to go from B to C, or the long route. Now, the long route, we still use B, one endpoint. We still use C, another endpoint. And for our third point, we pick any other point along the route. So I may see students call this BAC. I may see some students call it BDC, and both are correct. It really doesn't matter as long as that middle letter is some point on the route of that major arc. And last but not least is semicircle. Okay? Now what the heck is a semicircle? A semicircle is half a circle, exactly 180 degrees. Now typically, and I say this typically because it's about 98% of the time, you see authors of books, or when they're talking about semicircles, use three letters to identify a semicircle. Because again, if we're talking about BD, the segment being a diameter, we can go around the circle one of two ways, from B to D, both semicircles. So typically what I would see is someone say, well, I'm talking about semicircle B through A to D. And they would use that. Three letters to name a semicircle. And if they wanted to go the other way, there'd probably be another letter between B and D, or they'd probably name it B, C, D going this way. So those are your three types of arcs. And then we get to something called a central angle. And now a central angle is an angle, just like before. Every angle we've dealt with since the first week of school. That's vertex, or who has a vertex at the center of the circle. So right now I don't have any central angles drawn in. But if we were to erase that and create this angle here, this would be an example of a central angle. And the thing about a central angle is, whatever the measure is, if it's 40 degrees, whatever arc lies in between the sides of that angle, so this part of the circle is also 40 degrees. That leads us to the problems now. Okay. What the heck is this asking? This is going to ask us to find the measure of arc B to D. How many degrees is it from B to D, the short route, because it is a minor arc? And the second question, how many degrees is it from B through E to D the other way? So there's a few ways we can do it. But my philosophy all year has kind of been, find as much information as you can, and then go back and answer any questions. Almost ignore these, okay? Go with what you know, all right? Going by our philosophy here, a central angle is the same measure as its arc it intercepts. So if we come over here and if we notice that this angle here is 40 degrees, we notice from E to D on the circle that arc is also 40 degrees. Start to fill in what you know. If we notice an angle here is 75 degrees, or I should say an arc, B to C is 75 degrees, we can trace that back to the center and say, well, this angle is 75 degrees. Now, there's a ton of stuff you already know from first semester, again, from September. You know vertical angles are congruent. So if you see that X, and I do, then those two angles have to be the same measure. So again, if this is 40 degrees, this angle is 40 degrees. And you can take this 40-degree angle, because it's a central angle, and trace it to the arc, and say A to B is 40 degrees. Oh, what else do you have, Mr. Johnson? Well, other things. We know straight lines have 180 degrees. You probably knew before that that half a circle has 180 degrees. So when I look at this diameter, there's a straight line. So that means this half of the circle has to add up to 180. So knowing that, this angle here has to be 140 degrees, because together they have to add up to 180. Or maybe you said this arc out here is 140, because arc AE and this little arc AB make a full half, or I should say make a semicircle, 180 degrees. So fill in what you know. I've seen people do this all different ways. The last little piece here, arc CD, or our central angle, I've seen people do some crazy things with. Okay? Some people will look at this and say, well, there's a half a circle, so they'll do 180 degrees minus this 75 minus this 40 and come up with the answer. Other people will look, and for them it's easier to see the whole 360-degree circle. And they say, hey, if we look at this circle, we know this piece, and this piece, and this piece, and this piece. So the only piece they're missing is that arc CD. So they'll take all these numbers, add them up, and subtract from 360. Regardless how you do it, you're still going to come up then with that same answer of 65 degrees. And once you come up with that, all that information, and I should put the 65 out here, now it's easy to go back and answer questions. Now it's easy. If you have all the small parts, now it's just really adding numbers. And so when you get to the problem, and the original problem says, well, what's the measure of arc BD? This is arc BD. Here, so it includes 75 degrees. Here it includes 65. So you're really saying, well, can we do 75 plus 65? Because if you can, that's your answer. What about this? Arc BEC. Okay. Well, now you're going to start here at B, go through E, so you're going to include that, include that, include that, go all the way back here and include this. And again, we can add all those little pieces up. Or what some people may say, well, wait, if we're going from B to C the long way, we're just not including the 75. So some people will add all the small numbers up. And some people might say, well, 360, the whole thing, minus this one piece, which we don't need. And if they do that, they'll come up with 285 degrees. So what I'd like you to do here, I have a couple problems, a picture like this, I'm going to put up behind me. I want you to try to answer the 3 questions on here, or 2 questions on here. The other thing I need an answer for is this. I'm going to ask on the Google form a Star Wars question. Okay? That question is, who killed Greedo? Okay? Who shot Greedo? See if you can Wikipedia or Wikipedia that before you answer it on the multiple choice. But main focus, answer the questions I put up for this problem right here. Answer these problems. Try these. Find the measure of arc AB. Find the measure of angle CMD. And find the measure of arc BCD. So focus on measuring these, and again, try to figure out who shot Greedo as well. And just answer these, put the answers to these questions in the Google form that's right below the video. We'll see you tomorrow in class. Peace.